Okay, so this is a number 4. Essentially, it's question about the redox reaction. And so they are asking this. There are two reactions, and the first reaction is this. Second reaction is that. One reaction involved with changing N2O5, mixing with the sodium bicarbonate ion, and then they becomes CO2 and water and sodium nitrate. Okay, and I think there's something wrong here because this one must be a this bicarbonate ion must be a neutral as it is, so it should not. It should be a neutral as they are because I think that I can see myself. Sodium becomes sodium plus HCO3. No, okay, HCO3 bicarbonate ion should be the ion like this. Okay, and so the which one is a redox reaction is the question. So redox reaction means reduction plus oxidation. In chemistry, the reduction means you are acquiring electrons and losing electrons for the atom wise, and we talked about oxidation number is coming down, that's on reduction, and oxidation number for the atom is going up, which is essentially the oxidation number is a fancier way of calling the charge on each atoms, and that's an oxidation. So these are the two different categories that we combine, and the redox is essentially comes in pairs. Something lose an electron, something acquiring the electron, just like a acid-base reaction. This is similar to that. So what you really need to establish whether which one is a 1 or 2. So to answer this question, and which compound is oxidized, which is not, and you need to list it out all the atoms. Okay, so N2O5 here, so there's a nitrogen here, there's an oxygen here. And which is more electronegative? This is oxygen is more electronegative, so there will be -2 their oxidation number, and so because this is being like that, so that's a -10. So nitrogen is being forced to have +5. So this is their oxidation number. As far as the product is concerned, the NO2, the nitrogen compound is here, which is sodium nitrate, so Na plus, NO3 minus. So once again, oxygen-wise, the oxidation number is -2 because they are more electronegative, and they are forcing the nitrogen to be essentially nitrogen oxidation number plus 3 with a -2 oxidation numbers is a -1, right? So therefore, this is oxidation number is 5. So as far as the oxidation number wise, the nitrogen oxidation number stays the same, so there's an oxygen here. So nothing get reduced or oxidized as far as a nitrogen containing compound is concerned. And we can also look at the second case, which is now sodium in left side becomes a sodium plus, so that's a +1 and a +1. So the oxidation number stays the same, and then the NO, this is a bicarbonate, right? So that's a bicarbonate, and so which is a HCO3 minus. So hydrogen is a +1, and the carbon and an oxygen. So what's going to happen for the oxygen and the carbon, which is more electronegative? Once again, oxygen is more electronegative. This is a -2. And so therefore, HCO3 minus, which is a +1 plus carbon oxidation number, And 3 oxygen means minus 6 is minus 1, right? So therefore, the carbon oxidation number is plus 4. Okay. So carbon is an oxidation number of plus 4. So that's what situation now. And if you look at here, and carbon containing compound CO2, oxygen and the carbon, once again oxygen wins, so that's a minus 2. And then this one is a neutral, so CO2, the oxidation number of carbon is 4. So as far as a carbon oxidation number is concerned, their oxidation number stays the same. So nothing gets reduced or oxidized. It remains to be the same. And as far as the hydrogen, H2O, I mean, it is a plus 1 and a minus 2 in this scenario, so it remains the same. So this is, therefore, it is not a redox reaction. Okay, so let's move on to the second case. Obviously, this one must be a redox case. So as far as a potassium containing one, potassium is potassium plus, and chlorine oxygen wise, so this one itself will be a chlorine O3 minus, right? So therefore, which one wins the competition for the electron? This one. So this one will have a minus 2 charges. Therefore, this is chlorine plus, there are 3 of them, so minus 6 is minus 1. So the oxidation number for chlorine here is plus 5. Okay, and then there is N nitric acid, so H is a plus 1, and then this one becomes NO2 minus, so therefore nitrogen and an oxygen. Once again, the oxygen wins, so minus 2, and then the nitrogen wise, this must be a plus 3 to make the overall charge of NO2 as a NO2 minus, right? Because NO2 minus is what to make this, that's the oxidation number. Once again, to make this ClO3 minus, that's the oxidation number. So at the end, now you have this compound, KCl, potassium chloride. Potassium is a plus 1, and chlorine must be chlorine minus. Okay, so now we have something here. The chlorine used to have an oxidation number 5, but now become oxidation 1. So their oxidation number is reduced. So this is the reduction. Okay, and what else do we see here? HNO3, which is a nitric acid, and then H is an H plus 1, and then we can say NO. Once again, nitrogen wins, the oxygen wins, and then H, by losing it, NO nitrate ion, so that's a minus 1. So therefore, this is a minus 6 is nitrogen plus, minus 6 is minus 1. So now for nitrogen, oxidation number is plus 5. Okay, so now from what used to be oxidation number 3 is now this one is like this. So this one is oxidation number goes up. That's an oxidation. Okay, so therefore this one is oxidation number of chlorine atom decreases, and whereas the oxidation number for nitrogen increases. So therefore, this is a redox reaction. Redox reaction. And which one gets reduced? So now we can say first KClO3 is reduced, right? And so therefore, this is a reduced means this one is making the other, right? The other means the HNO3 be oxidized, right? So therefore, this one itself is also known as oxidizing agent. So when we call something as an oxidizing agent, means this one itself is being reduced, enforcing the other compound to be oxidized. And so that's the one. So we can have the same story for the second case. I will use a different color. Number 2, the HNO2 is reducing agent, making the other one to be reduced, and also this one itself is being oxidized, right? So this reducing agent itself is being this one itself is being oxidized. So that's the answer for the what was asking in here, because for the reaction which compound is oxidized, or which one is oxidized, which is a reducing agent, that's HNO2, which compound is reduced, that's an oxidizing agent, KClO4. Okay, so those are the names that on the redox chemistry people are using: oxidizing agent, reducing agent, and those are the different ways of how people call those. Okay. Thank you for your attention.